Welcome to the first lecture in software testing. My goal is to give you a solid background on software testing and also to make it quick. My audience should be any software engineer or IT that's plans to get involved in software testing, or any person that's going to be involved in software procurement or software certification. Now, this first lecture is going to be on the scope of verification. Now, you should understand that once you are done with your software testing, the functionality of your system remains the same. What I'm meaning is that after you spend all this budget in software testing, you did not add to the functionality. Also, once you are done with your testing, if you did not find any issues, then it was a waste of time. So the point is that you need to have some kind of a strategy that justifies the amount of budget and resources that you're going to use for your testing. And you always have to keep in mind that as far as your customer is concerned, value for him is getting the right quality for the right price. In other words, if you, for every piece of software you get, you spend a lot of budget and effort, regardless of the function of the software, you could end up with products that are just too expensive. Also, you have to realize that it is impossible for you to test the software completely. Now, what does it mean to test the software completely? It means that you're going to test all the valid inputs. You're going to test all the invalid inputs. Right there you have infinite test cases. You're going to test also all the variation of timing and test every path the program can take. So what this means is that you cannot test your software 100%. So you need to come out with some kind of a strategy to see what test cases you're going to prepare to test your software. So right now what we have is, first place, the scope of your testing. You need strategy. So it is money well spent. And secondly, the scope of your testing, no matter what happens, you are only going to be able to test a subset of all the possible test cases. So at this point, what I'm going to do is I'm going to give you two examples that kind of gives you the flavor of how to go about determining the scope of your testing. So in this first, before I get started with the example, I would like to make sure that you understand that the software testing coverage is derived from the system. You don't look at your software and then by looking at your software standalone decide how much you need to test. The scope of how much you need to test, the scope of your testing comes from analyzing the system. So in this first example, what I have is a autonomous vehicle parallel parking system. So basically what you have is you drive your car to a location, you get to your location, then the operator presses a button and the car automatically parallel parks. So for this particular function we have, I call it function 1. So we have function 1 is autonomous vehicle parallel parking. The input to this function is going to be sensor data. So basically what you have out here is a sensor that's going to tell you, or it's going to give the software all kinds of information associated with the vehicles around you and obstacles and whatnot. And then the software will evaluate the data that it's getting, and based on the data it's going to send rotary wheel commands to probably some kind of an actuator that will actuate the wheels. So that's what we're going to analyze. So what we have is autonomous parallel parking. You have sensors provide information to your software, and your software, based on the information of the sensor, commands the wheel to rotate. Gives command to an actuator that will rotate the wheels. So let's analyze this. Okay, so the first step in our analysis is going to be to create a hazard analysis. So a hazard analysis is an analysis that you're going to make to figure out how much damage your software can do if it misbehaves. So the hazard analysis is a matrix where you have in the headings, the top is going to be the component name, failure modes, how the thing can fail, whether or not it's detectable, and the outcome. Now let's get started. So you have components going to be functionality 1, which is this one here. Now the failure modes, this is usually if you have a sensor that is providing data, the failure modes, you should always use these 3 failure modes to get started. So the first failure mode is that no data from the sensor, you get no data from the sensor. The second failure mode is you get data from the sensor but it's out of range. This means that if you are supposed to get the value from the sensor, let's say from 1 to 5, and you get 6, well, you know that the sensor can only provide 1 to 5, for example, volts, and you're getting 6, so that thing is out of range. And the third failure is you get valid data. So if you're supposed to get value between 1 and 5, you get, for example, a 3, which is valid data, but the sensor is broken and it's giving 3 even though it should have given you a 2. So that's data from the sensor is in range, but it's erroneous. So let's analyze this. So in the first failure mode, no data from the sensor. In this case, the software realizes that it's not getting any new data from the sensor. So detectable, yeah, it's not getting data. And the outcome will be, for example, the software could decide, okay, if I stop getting data in the middle of my parallel parking function, then I will stop, and then I would light up some red light and tell the user that I'm broken, and the user can continue to parallel park on its own or drive away. So the second case, data from the sensor, is it detectable? Yes, it's detectable. And the outcome will be same as before. You detect the problem, it's out of range, and you do the same thing as before. Now let's go to the third case. Data from sensor is in range, but it's erroneous. Is it detectable? No. In the architecture that we have here, it is not detectable. So what would be the outcome? So we have may result in damage to multiple vehicles and injury to occupants. So what I'm saying is the sensor failed in a mode that it sent you incorrect data. The software evaluated incorrect data, and it gave commands to the actuator to move the wheels, and it hit another car. So somebody could have destroyed their car, or could have hurt somebody or hurt yourself. So at this point we need to go back to the drawing board. Either we have to think, hey, this sensor is going to have to be infinite good that it never fails, or we need to come out with an architecture. Now, in this case, we decided that we wanted a different architecture. So what I came out with is a 3-sensor architecture. So what we do in this case is you have some kind of an algorithm that evaluates those 3 sensors and decides what data to use. For example, could always look at 2 sensors, and if the data between that 2 sensors disagree, then you look at the 3rd sensor, and it's the tiebreaker to see which one is which data they should use. And if the 3 of them disagree, well, then you stop the function. So now what you have to make sure in this case is that the sensors have different failure modes. You may want to buy sensors that do the same from different manufacturers, because if you have the same failure mode, well, you have nothing, because 3 of them can give you invalid data. So now at this point we should look back at the software, and we have to realize that if the software mishandles the input from the software, from the sensors, I'm sorry, then you could end up with, again, going back to the hazard analysis we had before, the hitting another car or somebody getting hurt. So the software can do a lot of damage. So let's see where we are, and based on this information, how we decide the scope of our testing. Okay, software testing scope. First place, the analysis was done at the system, derived from the system design analysis, not by looking at the software. System design analysis. Secondly, in this case, the software must meet some kind of industrial standard and certification requirements. Now, why do I say this? It is because if your software is not designed per some standard or some certification, is not certified, then what happens is, in the case you have an accident and you have litigation, then you could be in deep trouble. So you have to make sure that you meet industry standards and certification requirements, and that should, over the years, have shown that if you meet those requirements, things should work. You've done your best effort to make sure that things work correctly. So again, in here we have the scope of your software testing is given. It's straightforward. You need to look for industry standards and certification, and you have to certify it. You're going to have to use some certification requirements to test, to validate it. So let's go to another example. Okay, in this case, my second example is a radio station tuning. So what you have in this case is a radio that gets tuned by a rotary encoder that is analyzed by the software. So in the old days, you would have an analog knob that you would move. It would be basically like a potentiometer that gives you different voltage. But these days, with the new technology, what you use is an encoder, which provides pulses that the software counts and decides which station it wants to go to. So what we have here is the functionalities radio station tuning. The input is an encoder position. The process, what your software is going to do, it's just going to count a number of ticks on the rotation, and it's going to go to that particular radio station. And the output is going to be that you get to the right station, radio station, and you get and you get your music. So again, we go to the system level and we go through our hazard analysis. We have, in this case, our three probabilities: no data from the encoder, incorrect data from the encoder, or encoder provides correct data but it's invalid data. It's within range data but it's invalid data. So in this case, no data for encoder. Is it detectable? No, because either you are getting no data because the user is not rotating the knob or it's broken. So the outcome would be it stays in the same station. The second case, it's out of range. Well, you know it's out of range, and then you can decide, this software organization can decide what they're going to do with that case. Either they're going to live in the same station or they're going to be to a predetermined station if they have a problem. And in the third case, where the encoder provides you the incorrect data, is it detectable? No, because I mean somebody rotated the knob and it gave you some kind of a gave you so many ticks, and you go to that station, and basically, but the outcome is that you have the incorrect station. So what happens now? So in this case, nobody's going to get hurt if this goes to the wrong station. So we don't really have any certification requirements or any industry standard that we definitely have to follow. So what determines the scope? So the software testing must be basically good enough. That's what I mean. It has to be just good enough as defined by the by management, marketing, and sales. They will give you the amount of budget that you need to get this thing done. Now, it could be that the radio is the most important thing in the vehicle, and that's what's going to define whether people buy or do not buy your product. In that case, well, you may have to do a little extra testing. So let's just wrap this whole lecture. So the question is, when we started, was what determines the scope of verification and validation? So it may be the scope of your testing may be defined by certification and industry requirements, first place. And in that case, you are going to get whatever budget it takes to get the job done from your organization. The second item, the second way the scope and verification of your program is determined is by marketing and sales. They may decide that your product has to be this good, has to work most of the time, if not all of the time. But also, for example, in an entertainment system, in a first class in an airplane, well, marketing could come and say, you know what, this system has to always work, no ifs or buts. We have folks here that have paid a fortune to go in our airplane in first class or business class, and when they push the button to watch a movie, that movie better be playing. And it's very important to be able to sell this product. So in that case, therefore, that you put in for a entertainment system may be as much effort as you put for something that is being certified, and you may meet all the industry standard plus. Okay. So this marketing sales, that can be like nothing or could be like very much. And finally, you have the best effort. You have a little toy or something that has a little bit of software. So your management says, hey, here you have the product. Make sure that it works. and then they'll give you a little bit of budget, and that's going to drive your system. So anyhow, I think I hope you've gotten an idea about how to define the scope of your testing. And as I mentioned upfront, this is quick, and also don't forget to subscribe. My next lecture is going to deal with the software life cycle and the role of the software engineer in the software life cycle. So I hope you've enjoyed this lecture, and hope to see you in the next one. Thank you very much, and goodbye.